This is question 18 from IIT JAM 2022. The question is, a planet of mass m moves in an elliptical orbit. Its maximum and minimum distances from the Sun are capital R and small r respectively. Let G denote the universal gravitational constant and m the mass of the Sun, assuming capital M greater than small m. The angular momentum of the planet with respect to the center of the Sun is what? This is the options given. Okay, so you have an elliptical orbit like this, and at the focus the Sun exists, and this is focus, and here the Sun okay, and this is the minimum distance. The planet moves like in this orbit, in elliptical orbit, and the minimum distance is smaller between Sun and planet, and the maximum distance is capital R. This is the maximum distance. Okay, this is the maximum distance. Now this is a central force motion, and the reduced mass of the system mu, that is equal to small m capital M by capital M plus small m, that is equal to small m, because capital M is much greater than small m. Capital M is the mass of the Sun, so mu is equal to m. Mu is reduced mass. Mu is reduced mass. Now the equation of the orbit in central force motion is d2u by d theta 2 plus u, this is equal to minus m by L square u square f of 1 by u, where u is equal to 1 by r. R is the radius vector from the focus. Okay, where u is equal to 1 by r, and if the force F is equal to, not F, L is the angular momentum, okay. Now solve this equation for F equal to k u square, where u equal to 1 by r. You will get what you will get L square by mk over r is equal to 1 plus root over 1 plus 2al square by mk square cos theta. Okay, this you will get, where k is equal to g m. G is the universal gravitational constant. Okay, capital M is the mass of the Sun, small m is the mass of the planet. So you have this type of figure, and this is the minimum distance, this is the maximum distance, this is capital R, this is small r. So when the planet has minimum distance, then theta will be equal to 0 degree. So the term cos theta will be equal to 1, and the radial vector will be smaller. Okay, so when r is equal to small r, then theta is equal to 0 degree. Then this equation you can write L square by mk over small mk by mkr, that is equal to 1 plus root over 1 plus 2a L square by mk square, and the cos theta will be equal to 1. So this equation 1. When r is equal to capital R, when r this r is equal to capital R, then theta will be equal to what? Theta will be equal to 180 degree. Okay, theta will be equal to 180 degree. So cos theta is equal to -1, and r is equal to capital R. So when r is equal to capital R, then theta equal to 180 degree. Then this equation will be L square by mk. You have to write capital R in, okay, you have to write capital R, okay, that is equal to 1. Now minus sign comes because cos 180 degree is equal to -1, so minus sign comes into root over 1 plus 2a L square by mk square. This is equation number 2. Now add these two equations, 1 plus 2. What you will get? You will get L square by mk 1 by r plus 1 by capital R, that will be equal to 2. Or by add this 1 plus root over 1 plus 2a L square by mk square plus 1 minus root over 1 plus 2a L square by mk square. So this two term will be cancelled out, that is equal to 1 plus 1, this is 2. So L square by mk into 1 into what will be this? Smaller capital R, r plus r, this is equal to 2. So you are getting L square by mk, L square by mk, small r plus capital R by smaller capital R, this is equal to 2. Now L square is equal to 2mk into r capital R by smaller plus capital R, okay, and L is equal to root over 2mk smaller capital R by smaller plus capital R. So we know k is equal to g capital M small m. So put the value of k here. So it will be 2 m. K is g capital M small m smaller capital R by R plus capital R, that will be equal to m twice. So m, it will give m into root over of 2 g m small r capital R by smaller plus capital R. So L, angular momentum L, is equal to m root over 2gm r by smaller plus capital R. This is the answer. This is the answer. So let us find which option is correct. Here this is 2gm r. So this 2 2 GMMR. No. M root over 2 GMMR. This option. Option A. So option A is correct, because we get L, angular momentum, L equal to M root over 2 GM R by R plus R, not 2M, only M. Okay, so this is the answer.